In this particular session, we're going to discuss about a term called compound annual growth rate, CAGR, which is one of the fairly important concepts that is used in finance as well as in any kind of domain where general growth parameters would have to be discussed somewhere. CAGR, as the name suggests, is a compound equivalent growth rate over a period. So, for example, if we take this case here, the company's sales in 2008 were 2,000 crore, and in 2015 were 8,000 crore. This would have grown at a certain rate, right? Now, the rate of growth could have been different in different years, but compounding 2000 multiplied by a certain growth rate in the first year, this would have been the number, then another G, 1 plus G over the many years. There are 7 years here. That should have given the number 8,000, right? This is a compounding kind of a question. So for example, if you invest 100 bucks in a bank account that gives you 10%, the first year you make 100 into 1 plus 10%, which is going to be 110. The second year on this 110, you make 1 plus 10%, so that becomes 121. In other words, you basically took 100, you took 1 plus 10%, raised it to the power 2, and that gave you 121. That's because we compounded the number. Now, the sales of a company also could have had the same number, 10% growth over the 2 years, but could have moved from 100 to 105 and then to 121. Right? So individual years growth could be different. What we are trying to find is what is the single number that when annualized gives this kind of a growth rate to us, right? So we need to solve the central equation that's there. Let's rewrite the equation again. We are saying 2000 growing at a certain rate, G, for 7 years gives me 8,000. We need to solve for G, which means 1 plus G raised to power 7 is going to be 8,000 by 2,000. We will again take now, because this is to the power 7, so both the sides will take the 7th root, 1 by 7, right? So this becomes 1 plus G, and this becomes 8,000 divided by 2,000 raised to the power 1 by 7. And then finally, if I solve for this, this becomes G is equals to 8,000 divided by 2,000 raised to the power 1 by 7 minus 1, because I took the 1 on the other side, right? So essentially, the formula is 8,000, which is the final value, divided by 2,000, which is the initial value, raised to the power 1 divided by the number of years minus 1, right? So I can rewrite the formula here. Let's rewrite it. We are saying the CAGR is going to be equal to 8,000 divided by 2,000 raised to the power 1 by 7 minus 1. In other words, if we generalize the formula, it's final number divided by the initial value raised to the power 1 by the number of years n minus 1. That's the generic equation we have to solve for. Let's calculate this data, right? So we need to put a bracket, CAGR bracket 8,000 divided by 2,000, close bracket, raised to the power, open a bracket, 1 divided by 7, close bracket, minus 1, right? So it'll first divide the brackets, then take the power based on our general mathematics rule of priority of the calculations, and then subtract 1 from that. What we get is a number which is 21.90%, right? Now let's check. If 2000 grows at 21.90% for 7 years, what does it give us? So that's 2000 multiplied by 1 plus 21.90 raised to the power 7, right? We get 8,000, which back calculates our data and tells us that we were correct in the calculation of CAGR. CAGR is an extremely important concept, keeps coming in a lot of discussions around what is the CAGR of a particular product for a marketing firm, what is the CAGR in terms of employee addition for a certain firm, what is the CAGR in terms of overall sales growth or profitability growth of a particular firm in finance, right? So this is an important concept. Just keep this in mind. I'll repeat the formula. Essentially, we are trying to solve the simple equation of a number 2000 in this case growing at a certain rate g for a certain number of years and giving us the final value.